Greetings and welcome to the Chemistry 151 Density Lab, and we'll explore in this lab the relationship between the mass of an object and the volume of an object, and it should be a pretty cool experience. Before we get started, I just want to remind everyone that there are ways to get assistance on this lab if you need help, and the very best way is through email. You can email me at mike.russell@mhcc.edu, and I'm happy to help. Our website for this class is mhchem.org/151. That is always available to you with lots of information. I do have office hours this term, which are online, Mondays and Wednesdays, 10 a.m. to noon, and those are available through the Discord server. Go to that website there. It's specifically for Chem 151. You can ask questions if I'm there. We'll have conversations and stuff figured out. You can also leave messages for me there, and I'll get back to them as soon as I'm able to. So don't feel like you can't get any help. There's also the Learning Success /Avid Center at Mount Hood Community College. Lots of ways that you can get help if you need it. So density is just a way, as I said earlier, to relate the mass of an object to the volume. And all things have a density associated with them, and every substance is a little bit different, more or less. Density is just something expressed as a number. So for liquids, it's usually represented as grams per milliliter. So you can see there the units, grams per ml. That's what people usually will use when they're talking about the density of a liquid. Now, solids are usually in grams per cubed centimeters, or centimeter cube. And you can see the units there, grams per cm cubed. A cube centimeter is nothing more than literally a centimeter by a centimeter by a centimeter. So length, width, and height are all centimeters. That's where the centimeter cube comes from. Pretty chill. If we talk about the density of gases, which we won't do in this lab, gases are usually represented as grams per liter. And you can see the reason in that little picture down there. Solids have a lot of mass, usually per unit volume. You can see how they're all tight together there. On the other hand, gas on the far left doesn't have as many atoms per square. All right, not as much mass per unit object. Liquids are usually somewhere in between. And it does vary. There's different types of all three of those and stuff, but as a rule of thumb, that's how that rolls. 1 milliliter is defined as 1 centimeter cubed, so they are the same thing. So if you decided to call your liquid density as a grams per centimeter cubed, it's okay. And if you decided to call your solid as a gram per milliliter density, it's okay too. So do realize there's a little bit of interchange, but usually people use centimeters cubed for solids, milliliters for liquids. So you'll be hip, I guess, if you do that. Whatever, do whatever you want. In this lab, if we would have been doing it in the actual world, we would have used a combination of what's called a top-loading mass balance, and I've got a picture of one right there, as well as some way to measure the volume. And for the liquid part, we'd use those volumetric flasks. So we'd find the mass through the balance, the volume through some kind of a volumetric flask, and from there you can take the mass divided by the volume and you're good to go. So to find the density of the liquid, of course, you need the mass and the volume, like anything and stuff. The mass you can find from that balance. And literally, it's like you have like the container that's empty and the container that's full of liquid. And the difference between those two would be the mass of your unknown liquid. The volume, you do need some kind of a reference point. The density of water has been studied extensively. And so values of the density of water are known very accurately. So if you have a shut container that you can measure, you can use the density of water to find the volume of the flask, and from there you can use that for your unknown liquid. In the liquid part, we would use a volumetric flask to figure it out, after first doing the thing with the liquid water. To find the solid is a little bit different. Solids don't have flexible shapes. Their volume is very set. So like you can see up there the picture of the metal being placed in the water. So what people usually use is what's called Archimedes' principle of displacement, or just the displacement method. And this comes from the fact that Archimedes was given a task, supposedly by a king, to figure out if substances were real gold or fake gold. cold. And while sitting in the bathtub, supposedly, he realized that as he sat in the bath water, the water raised up. So adding a solid to water makes the water displace. And the difference of displacement will be the volume of the object. So you can see in the top picture up there that the beaker with water on the left without the solid versus the same beaker with water with the solid, the water has gone up. And that difference in solid, that delta V, is the volume of the solid, which is really cool. And so you can use Erlenmeyer flasks, the middle picture there, to do that kind of thing. This really only works if the solid sinks, which means if the density of the solid is greater than the liquid. And most of the time, that's the case. So that's what we would do in this lab, too. You'd use the difference through displacement to find the volume. The mass of the object or the solid, you could use, again, that mass balance once again. So that's not too hard. The volume is the more tricky one. By the way, there are people that aren't sure if there was really this eureka moment in Archimedes' life. It was apparently told by many people. I like to believe it's true, but who honestly knows if it is or not? But it's a cool story either way. So the goal of this lab, you'd find the density of an unknown liquid, grams per milliliter, and also the density of an unknown solid in grams per centimeter cubed. And the liquid part, again, pretty chill. You would use the volumetric flask and the mass balance. For the solid, you would use the displacement method to find the volume of the solid. The mass comes from the balance and stuff like that. It's pretty chill. In addition to learning about density on this lab, this is also a significant figures lab. So make sure you watch your significant figures rules when you're doing calculations. There's both multiplying and dividing, i.e. the actual density calculation part, but there's also some addition and subtraction when you're taking the mass of the flask filled with the metal and water minus the flask with just the water, that kind of stuff. So watch out those kind of things. At this point, I think it's time to watch a video on how this lab would have actually gone down. And again, if you have questions on any of this, please let me know. Good luck.